Math 3, Unit 9, Section 3 Notes. Today we're going to be solving and evaluating exponential and logarithmic equations with common bases. We will worry about different bases later on. So right now we have all of these exponential equations which have bases raised to an exponent, and it gives you an answer. What we are going to do is rewrite each side of our equation so that they have the same exact base. So like 81 right here, for instance. 81 can be rewritten with a base of 3 because you can write 3 to a certain power gives you 81. So that's our first step. So all of these numbers, 16 can be rewritten as 2 to some power, etc. So we're going to do that first. Then you're going to notice that because the base matches on each side, we can then set our exponents equal to each other, and then we'll solve for x. So let's follow these steps and just start solving. So number 1, rewrite each side of the equation to have the same base. So 3 to the x is going to stay exactly the same because 3 is a prime number. I can't make that any smaller. And then I'm going to rewrite 81 as 3 to the 4th power. All right, and then since I have a fraction here, we know that these don't match up perfectly, so I want to take that denominator, move it across the fraction line, and anytime you move a base across a fraction line, its exponent becomes the opposite. So right now it's positive 4, it's going to change to a negative 4. Now you can notice that our exponents are in the same exact spot, right? So all this means is that because the 3's are exactly the same, then our exponents are equal to each other. So we get x is equal to negative 4. Okay, let's try that again. So we're going to leave 2 to the x, but we're going to change 16 and write it as 2 to the 4th power. Again, it is a fraction, so we're going to move it across the fraction line. 2 to the x equals 2 to the negative 4th, which means x is equal to negative 4. As long as those 2's match, then their exponents are equal to each other as well. All right. Okay, my base on the left is 2. The exponent has a lot going on there, but that's going to be okay. There's a number on the other side that is not written with the same base, so we're going to rewrite that part. All right, 8 can be rewritten with a base of 2, just like this has a base of 2. So 2 to the 3rd power gives me 8, so we're going to rewrite it like that. Excuse me. Okay, now since the bases are the same, then that means their exponents are equal. So these exponents that are in the same spot, we're going to set them equal to each other. But I don't have my answer yet because I should be solving for x. So we're going to go ahead and solve for x. So you can do a couple things. You can divide the negative to the other side. You can distribute the negative. I'm just going to divide it to the other side. So if I divide this by negative 1, a negative divided by a negative is positive. So this becomes x plus 3 equals negative 3. And then I can go ahead and subtract the 3 to the other side. And we get x is equal to negative 3 minus 3, which is negative 6. X equals negative 6. And that's that problem up there. I shouldn't have left so much space. Okay. All right, going on to the next problem. Remember, first step is to write both sides with the same base. So right now, I have a 4 and a 2. So that means I can rewrite the 4 as a base of 2 2 to what power gives me 4? That's 2 squared. Now, this 4 was already being raised to the x plus 2. So we have a new exponent, which means I need to multiply that by my previous exponent. Now, and the right-hand side of the equation is still 2. The reason for that is because I have this 2 squared is equal to 4, and we know that our power to a power rule means to multiply for exponents. So if you have a power raised to a power, it means you multiply the exponents together. I won't always write that as a power to a power in that way. We just need to remember that we're going to multiply this together. But I can rewrite it as actually multiplying the 2 times the x plus 2. Now, my bases are the same, but the right-hand side seems to not have an exponent, but we have to remember that even if the exponent is not written down, there should be one that exists. So 2 is 2 to what exponent? 2 to the first is the same as 2. So I'm going to set the 1 equal to the other exponent of 2 times x plus 2. All right, so we have 2 times x plus 2 equals 1. Those are the two exponents. Left exponent, right exponent. 2 times x plus 2, you can either divide the 2 first or you can multiply it through. It's up to you. I know you like to distribute, so 2 times x is 2x, 2 times 2 is 4. Then we're going to solve for x. So we're going to subtract 4. So 2x equals negative 3. And last, we're going to divide by 2. So then we get x equals negative 3 over 2. And yes, you can have fractions as answers. All right, moving to this next one, we have 7 to the 2x and 49 to the 3x minus 2. Same thing, we're going to do 7 to the 2x is going to stay the same, but we're going to rewrite the 49 as 7 squared. And remember, you're raising 49 to the 3x minus 2, so you're going to multiply those exponents together. That gives us 2x equals 2 times 3x minus 2. The 7's are the same, which means the exponents are equal. I'm going to go ahead and distribute on the right-hand side. 2 times 3x is 6x. 2 times negative 2 is negative 4. Let's get all of our x's on one side, so we're going to subtract this 6x. And then divide by negative 4. And we know that negative 4 divided by negative 4 is 1. So on both sides, we should get x equals 1. That's a positive 1 because a negative divided by a negative is positive. All right. Moving down to the next ones. Now, I cannot rewrite 27 as 9 to a certain power. Well, I can, but it's going to be a fraction. So instead, we're going to make our lives easy and not do those fractions. We're going to change both sides of this problem because they both have the same prime number that we can write as the base. So how can we rewrite the 9? You should have said 3 squared is 9. So we're going to multiply that by its exponent of 2x. How can I rewrite 27 with the base of 3? Because we want the bases to be the same, so it has to be a 3. You should have said 3 to the third. We multiply that by the existing exponent, x minus 1. All right. And then we set our exponents equal to each other. So 2 times 2x equals 3 times x minus 1. We're just going to multiply. So 2 times 2x is 4x. 3 times x is 3x. 3 times negative 1 is negative 3. Get all of your x's on one side. So we get x on the left. 3 minus 3x is 0. And so x is equal to negative 3. All right, moving to the right. We want to rewrite these exponents with the same base. So let's start as writing the 27 with a base of 3. 27 is 3 to the third power. But I don't want to set these exponents equal to each other because one of these is in a square root and one's not. So let's rewrite them both in exponential form. Remember that the index of a square root is 2, so when I rewrite the right-hand side with it as an exponent, it should be 3 to the 3 over 2. The left side's going to stay as 3 to the x. Remember, exponent is your numerator, index is your denominator. That's where I got the 3 over 2 from. And then what's in the same spot? X and 3 over 2. So that means x is equal to 3 over 2. All right. Go ahead and move to the back side. All right. Now, the other side was exponential equations. Now we have logarithms. So before we start solving for our logarithms, we are going to remember our what power function. Remember, this means what power do you raise 7 to get 49? So we should already know that. Our answer should be 2. But if we're solving it as an equation, it helps us to show our process because sometimes we can't get straight to the answer because there's a lot going on in the process. So what we're going to do with log base 7 of 49, the very first thing you're going to do is set the equation equal to x. Okay, eventually I'm going to get x is equal to 2 because we can already see that those are in the same place. But the next step is to rewrite the equation in exponential form. So 7 to what power gives you 49? Then you rewrite each side of the equation to have the same base. So that would be 7 to the x stays the same, and 49 is 7 squared. And last, we set our exponents equal to each other when we have the same base. So these exponents that are in the same position means that x is going to equal 2. So while I start off by making an equation, we also solve for that x value that you've put in there. Okay, so for all of these equations, you're going to set them equal to x, and then we're going to solve for them. So you won't have your x as your answer quite yet. We're going to save that for the very end and just write x equals 2. All right, so for the next one, rewrite into exponential form. 3 to what power equals 1 over 27. Rewrite both sides to have the same base. 27 is 3 to the third power. Well, we need to write these both as 3 to a power, not 1 over 3 to a power. So this would be 3 to the x equals, well, if we move that denominator across the fraction line, that positive 3 of an exponent becomes negative 3, which means these exponents that are in the same position, x equals negative 3. So we created an equation by putting x there, and we found our answer for x equals 3. It helps us to evaluate the logarithm. So we get -3 for log base 3 of 1 over 27 equals -3. But you can just leave it as x equals -3 if you write that your logarithm is equal to x. Okay, so again, step 1, set the equation equal to x. Step 2, what power do you raise 5 to get 5 root 5? We're going to rewrite each of these in exponential form, because the right hand side is not, we have an exponential form for our equation, but we also have a radical form within that. So we want the same base here, and we have to condense some stuff. So let's leave the 5 to the x the same, but then we're going to do 5 times, how do I rewrite the square root of 5? Well, we know the exponent there would be 1/2, so this would be 5 to the 1/2. So we have 5 to the first times 5 to the 1/2. If you have bases with the same base, what do you do with their exponents? You should add them. So you have 5 to the x equals 5 to the 1 and 1/2, which we normally write as 3 over 2, because that equals 1 and 1/2. Remember, 2 over 2 is 1 whole, and then another half would be another 1. So 3 over 2, there are 3 halves. Okay, so just backtracking those steps, we did 1 plus 1/2 is 1 and 1/2, and I changed 1 and 1/2 to 3 over 2. And then our answer for x would be 3 over 2. Because those exponents are in the same place. All right. Again, set your logarithm equal to x, so then we can solve. This means, what power do I raise 5 to? What power do I raise 5 to? To equal the cube root of 1 over 25. All right, let's start by changing the 25 to a base of 5. (25) is rewritten as 5 squared. Remember, we're going to move this across the fraction line and make the exponent negative. So that would be 5 to the -2. Now we're going to rewrite this radical in exponential form. So I raise the 5 to the exponent over the index, so -2 over 3. And what exponents are in the same spot? X and -2/3. So our answer here is x equals -2/3. Okay, next one. Remember, set it equal to x, because the logarithm means, what power do you raise 1/2 to get 16? All right. Whenever we see these fractions, we want to move them across the fraction line. That means my exponent becomes negative. What exponent is here to start with? A 1. So that exponent is going to become a -1. So my base is 2, because that's my prime number that we're using on the left. Can I rewrite 16 with a base of 2? Yes, that's 2 to the 4th power. Okay, this is power to a power again. What do I do with those? Power to a power, I multiply them. So this is -x equals, well, 2 to the -x equals 2 to the 4th. So what does -x equal? -x equals 4. What does positive x equal? Divide both sides by -1, and you should get x equals negative 4. Almost didn't write that. Divide each side by negative 1. And that's how we get x equals negative 4. All right. Again, set your log equal to x. Because this means what power do you raise 4 to? You get 16 square root 4. Okay, we have a couple different options here. We can change the 4 to a 2, but because 16 can be rewritten as 4 to a power, and because the square root of 4 can be rewritten as 4 to a power, I'm going to go ahead and leave the base as 4. You can change it to a 2, but as long as you can get them the same, you don't have to. So 4 to the x, we're going to leave the same. 16 is 4 squared, and the square root of 4 is 4 to the 1/2. What do you do with 4 squared times 4 to the 1/2? You add their exponents together, so this is 4 to the 2 1/2. I'm going to rewrite that as a mixed number, which would be 5 over 2. So x is equal to 5 over 2 because those are your two exponents. All right. Do you remember what this ln means? The natural log. The natural log has a base of e. So this would mean e to what power gives you 1 over the square root of e. We're going to change that square root to a 1/2. How do I bring it up to the numerator? You make the exponent negative. So x is equal to negative 1/2. Go ahead and flip to the other side. Solve each equation for x. Okay, so when you have a logarithm with the same base on either side, then that's saying what power do you raise 2 to get 3x? What power do you raise 2 to get 96? Those two powers are equal to each other. In other words, if you raise 2 to that same power on either side, you should get an answer that's the same. So it'd be like rewriting each side as 2 to something equals 3x, and 2 to the same number equals 96. You don't have to write this part down, but if those two values are going to be the same exact number, then these two answers should be exactly the same. So what happens here is it's not necessarily, if you have the same exact log, see log base 2 on either side, then that means 3x is equal to 96, or your two answers are equal to each other. Then all you have to do is divide by 3. What is 96 divided by 3? 9 divided by 3 is 3, 6 divided by 3 is 2, so we get x equals 32. All right, see how my log base 5 is the same on either side? That means my answers are also equal. How do I solve for x? Right now it's being divided by 7. We multiply by 7. So we get x equals 28. 7 times 4 is 28. All right, see how the log base 6 is the same on either side? That means their answers are equal to each other. All right, the 9 and the 27 again. Don't forget, you can write 27 with the base of 9, but you don't really want to. So we're going to rewrite both of them with the base of 3. 9 is 3 squared. I'm still going to have the exponent of x. So if I rewrite the 3 squared to the x power, that means I'm doing 2 times x. And 27 is 3 to the 3rd power. So 2 times x equals 3. What did I do here? I set my exponents equal to each other. What am I going to do now? 2 times x equals 3, which means if I divide each side by 2, I get x equals 3 over 2. If the natural log is on either side, we still have a log with the same base. It's base e, which means my answers are still equal to each other. 3x plus 7 is equal to 4x minus 8. What should I do? Get all of our x's on the same side, so subtract that 3x to the right-hand side. 3x minus 3x is 0. 4x minus 3x is x. Now you can bring everything else down. And then add 8 to the other side. You could have done that at the same time. Negative 8 plus 8 is 0. 7 plus 8 is 15. So x equals 15. All right, now be careful. We cannot set 4x plus 5 equal to 2. Why not? They don't have the same log on either side. There's only a log on one side here. So instead, we are going to change this to exponential form. This says, what power do you raise 3 to get 4x plus 5? You raise it to the second power. So we're going to change this to exponential form. Your base raised to your exponent equals 4x plus 5. All right, what is 3 squared? 9. How do I solve for x? If you said subtract 5 and then divide by 4, you are correct. 9 minus 5 is 4. So when we divide by 4, 4 divided by 4 is 1. We get x equals 1. Same thing here. I don't have logarithms that are the same on either side, so I can't essentially cross them off that they're the same, which means I'm going to have to change to exponential form. So my base is e, my exponent is 4, my answer is x minus 3. All right, and we're just going to leave our answers as expressions. You don't need to plug this into the calculator and find the approximated value. We're just going to solve for x by isolating it. So if I add 3 to the other side, e to the 4th plus 3 stays as e to the 4th plus 3. So that is how you list your answer, is x equals e to the 4th plus 3. Okay, these last two, same thing. We have to change to exponential form because we do not know, or we do not have the same log on either side. Don't forget, if your base is not written, what is the base? How many figures you have? 10. So this is 10 to the x power equals the 5th root of 100. We can rewrite the 100 as 10 squared. 10 times 10 is 100. Then we can rewrite the radical as an exponent. What exponent would this be? Remember, 5 becomes your denominator, which means the 2 stays in the numerator. So x to the 2/5, sorry, 10 to the x equals 10 to the 2/5, so x equals 2/5. One more. What power do you raise x to? To get 25, you raise it to the 2/3 power to get 25. Okay, what do we do now? We want to solve for x. All of these other problems we solve for x. If I rewrote x with an exponent, it would be x to the 1st power. How do I get that exponent to be written as something to the first power. If I multiply it, the exponent, by its reciprocal, I have to do that exponent on both sides. 2 times 3 is 6. 3 times 2 is 6. This would be x to the first power, because that would be 6 over 6 equals 1, equals 25 to the 3 halves. We can rewrite this back into radical form, which would be the square root of 25 cubed. You can put the 3 inside with the 25 or on the outside. What does the square root of 25 give you? 5. So this is 5 cubed. What does x equal? 5 times 5 times 5 is 125. So 125 to the 2/3 power equals 25. All right, that's the end of section 3. Please check your worksheet 3 for what problems you need to do.